Okay, so this is the answers for yesterday's assignments. The other two were pretty straightforward, and you can always go back to the videos I posted yesterday, but this one was a little bit interesting because you're actually going to have to multiply by the conjugate twice. And if that doesn't make sense, you just, follow along, or you can skip ahead to the end and sort of see what I did. But if I'm multiplying this by the conjugate, which is x to the 1/4 plus 2, you actually don't get rid of, sorry, I just made a mistake there. Okay. You actually don't get rid of the fractional exponents on the bottom in the denominator. So if I do that, I'm going to get x to the 1/4 times x to the 1/4. Like bases, we're going to add the exponents. So I get x to the 2/4 plus 2x to the 1/4 minus 2x to the 1/4 minus 4. Up top, if I FOIL, x to the 1/4 times x to the 1/4 again gives me x to the 2/4. X to the 1/4 times 2 gives me 2x to the 1/4. 2 times x to the 1/4 gives me 2x to the 1/4. And 2 times 2 gives me 4. So just to clean that up, I'm going to recognize that these fractions can be reduced. So up top I get x to the 1/2. If I combine these like terms, okay, they are like terms because they're the same base raised to the same exponent, I would get 4x to the 1/4. Okay, and then the plus 4 up top, just from that guy, from the plus 4. Okay, so now in the denominator, again, what I can do is say that this x to the 1/2, x to the 2/4 becomes x to the 1/2. So that would give me x to the 1/2. These two are going to cancel out. Okay, same base, raise the same exponent. One's a plus 2, one's a minus 2, so give me 0. And then I just have this minus 4 over here. Okay, but unfortunately, and this is why I wanted to talk about this one, is because we still have a fractional exponent in our denominator. So what I'm going to have to do is multiply by the conjugate again. All right, I can hear most of you groaning right now. But we're going to do x to the 1/2 plus 4, x to the 1/2 plus 4. If I do that on the bottom, x to the 1/2 times x to the 1/2 gives me x. X to the 1/2 plus 4 gives me 4x to the 1/2 minus 4x to the 1/2 minus 16. Okay, up top here, this is where it gets kind of fun, but you're going to multiply x to the 1/2 times x to the 1/2 gives me x. X to the 1/2 times 4 gives me 4x to the 1/2. Let's change up the color here. Okay, then I'm going to have to multiply 4x to the 1/4 times x to the 1/2, which would give me 4x to the 3/4. All right. The reason is because, like base, I'm going to add the exponents. My exponents are 1/4 and 1/2. Okay, 1/4 plus 1/2 would give me 3/4. That's how I got this guy right here. Okay, so hopefully remember how to add fractions. All right, and then I get plus 16. Give me a little more space here. There we go. Plus 16x to the 1/4. And then I get 4x to the 1/2 plus 16. Okay, and let's just clean this up. So we have, on the bottom of our fraction, we have x. These two guys are going to cancel out, so we just have x minus 16. Up top, we're just looking for some like terms. So let's use my highlighter here. Let's add up some like terms. My like terms would be 4x to the 1/2, 4x to the 1/2, and that's actually it. So we're just left with x. Oops, nope, that's the highlighter. There we go. Okay, you get x plus 8x to the 1/2 plus 4x to the 3/4 plus 16x to the 1/4 plus 16. Now, some of you are asking, well, aren't the denominators the same with x to the 3/4 and x to the 1/4? They are, but if you're looking at x to the 3/4 and x to the 1/4, that would be the 4th root of x to the 3rd plus, that's a 3 down there, plus the 4th root of x to the 1st. And they're not like terms. Hopefully, if I write it like this, you can kind of see they're not like terms. They're different. They actually have different exponents, so you can't combine them even if the denominators are the same. Okay, when you're adding and subtracting like terms, when you're adding and subtracting, you want to look for like terms, and they are not. So that is your answer for this one.